Hello, my name is Celina Taramasco. These are my revisions for EGR 343 Exam 2 Version B. I will be redoing numbers 3, 4, and 6. Here is the front page, the answer sheet. So 3, 4, and 6. Alright, starting off with number 3, we are given that T allow is equal to 50 MPa and V is equal to 40 kilonewtons. The question is asking us to find the minimum required diameter of the bolt to the nearest millimeter. So d min in millimeters. Okay. So to find this, we know that the area is equal to N over allow so if we just plug these in, then we get 40 kilonewtons over 50 MPa, which fix these units. So 40 kilonewtons is equal to 40,000 newtons, and 50 MPa is just 50 newtons per millimeters squared. So when we calculate that out, these newtons cancel out and we get 800 millimeters squared. And we know that area is equal to pi times the diameter squared over 4. And we just found out that that is equal to 800 millimeters squared. So when we rearrange that and then solve for d, we get d is equal to the square root of 800 millimeters squared times 4 all over pi. And we calculate that out, we get d is equal to 31.9. So the minimum required diameter is equal to about 32 millimeters. And that is our answer. Sorry, my pen is dying. Okay. So moving on to number 4, we are given this figure. They let us know that alpha is equal to 2 degrees. This length is 4 meters, which is also 4,000 millimeters. And they want us to find the stretched length of BD in millimeters. So that's delta BD in millimeters. Okay. So moving on to the solution. Let's draw out a little diagram. So this is A, this is C, and then about here is B. And we have this angle, which they give us is 2 degrees. We're trying to find this change in length. And we know that this length is 3 meters or 3,000 millimeters. So from here we get delta BD, you know, is equal to the length plus the change in length, okay? And delta CE, we know is equal to the degrees multiplied by the distance. So we want to convert 2 degrees to radians, of course. So that's multiplied by pi rad over 180 degrees, and then times 3,000 millimeters. And with that, we get 104.72 millimeters. Okay, so delta BD is equal to 4,000 millimeters that's that L length, plus this change in L length, which we found is 104.72 millimeters. We'll add that together, we get delta BD is equal to 4104.72 millimeters. And that's our answer. Okay, moving on to number 6. This is our given figure. They are asking us to find determine the average shear strain. So that's this XY in the plate. Okay. So moving on to the solution. We know that shear strain in X and Y is equal to pi over 2 minus theta. And so let's note that this angle is theta, right? And this angle is beta. So we know that shear strain is equal to pi over 2 minus pi over 2 plus beta. And from there we can cross these out, these cancel out, so we get the shear strain is equal to beta, negative beta, sorry. So then we know theta is equal to pi over 2 plus beta, and using geometry equations, we know tangent of beta is equal to 3 millimeters, opposite side of the angle, divided by the adjacent side, which is 150 millimeters given to us. So 3 millimeters divided by 150 millimeters. We get beta is equal to the inverse tangent of 3 millimeters divided by 150 millimeters. When we calculate that out, we get 0.019997. So that means the average shear strain in the XY plate is equal to negative, because remember that the shear strain is equal to negative beta, so shear strain is equal to negative 0.01997. And that is, radians, remember to clarify that. And that is our answer.